Let's take a look at this question and how we're going to solve it. The first step to solving this problem is locating where oxygen is on the periodic table. Oxygen is in a group 6, so it has 6 valence electrons. It must have 8 dots around each oxygen. Let's draw it out. There are 3 oxygens in total, so we will then have to multiply 3 oxygens times the 6 valence electrons. After multiplying, we will have 18 valence electrons. Now we can draw our structures. First begin putting 2 dots around each oxygen. Remember, each should have 8 dots or electrons in total. As you can see, the oxygen in the middle is missing 2 dots, so we will have to share electrons with one of the outer oxygen atoms, creating a double bond. You can move 2 dots from one lone pair of valence electrons of the oxygen atom on each end. This structure can be drawn 2 ways. Now, let's look back at the problem. Choice A states that there are a total of 6 lone pairs in the Lewis structure shown. This is correct. Remember, a lone pair is a pair of valence electrons that are not being shared with another atom. Let's count the lone pair. Choice B states the central oxygen atom has 2 lone pair of electrons. This is not correct. The central atom has 1 lone pair. The other 6 valence electrons are being shared with the other oxygen atoms. Choice C states the structure has 2 different bond lengths. This response is correct because being that there is a double and a single bond, each hold different lengths. Double bonds are shorter and single bonds are longer. Choice D states the double bond in ozone would be easier to break than the single bond because it is shorter. This is incorrect. Double bonds are shorter, but they are also thicker and harder to break than single bonds. As bond length decreases, strength increases. Finally, we arrive to choice E. Choice E is also correct because it states that 2 of the statements above are correct. Those statements are choice A and C.